105 or Math 111, and if you didn't, we can chit-chat later. If you're worried, you shouldn't be worried. The textbook, I think, was freaking some people out. There isn't a physical textbook you have to have for this course, just like there wasn't one in Math 105. There is an online textbook I make reference to from time to time. You can click on this right here, and it opens it. It's 700-ish pages. Barbara Dean and Deb Alowski, I think the names, here they are. Barbara Alowski, Susan Dean, yeah, I had their names wrong. They created this monster, a 700-page monster of a free open source textbook. Take it. They said take it, print it, do whatever you want with it. Use it. This is where I think education should be. Because honestly, this is all available to you guys online in various places. What they did was took it all and put it in one place. The problem with doing that is as soon as you do that, it becomes outdated. It's like anything else. You got any rock climbers in here? It's like making a guidebook to a climbing area. As soon as you print it, it's out of date. And statistics is that way. But it's okay, because the topics in this book are not out of date. So I can refer back, even if the data set's 5, 10 years old, you can still practice the topic we're talking about, even if the data is a little bit dated. Might be referring to Ron Paul and his relevance. That's okay. As long as we're looking at the margin of error in those polls, it doesn't matter who we're talking about, whether it's Ron Paul or Rand Paul or whoever else has got their hat in the ring right now. So that's the textbook. If you want to buy one, I think it's pretty cheap. I spelled physical wrong. Sorry about that. $17.96, 18 bucks. If you want to buy a copy, it's about that big, about that fat, and you can totally buy a copy. By all means, you don't need. Yeah, I spelled physical wrong. Sorry, I'll fix that. But it's there for you if you need it. It's online. My goal this summer was to break it up into more manageable chunks and list those chunks. I failed. I apologize. Like I did with the Larson book in 105, but I never got around to it with this one, so apologies. But there it is. There it is for you. Just sitting there waiting. It's also the same one we use in 244 if you're taking 244. So hopefully we save you guys some money. The textbook, as I mentioned in the email to you guys, the textbook fiasco in this country is out of control. I'm not going to blame anybody because I think all of us are to some degree guilty of some little tiny, not students, students are not to blame, but everybody on either end is to blame. One of my former students is, I think I mentioned this in the email, nursing student, $1,600 for her first term of textbooks. I first became aware of it when I was in 1994. I purchased an abstract algebra textbook for 175 bucks. When I went to sell it back, they offered me 3. And I just kept that book on my desk from then on and just I will never do that to my students. And I've been working to get to this point. Now what I've done, and you'll see this, I've augmented this textbook in my own way without changing this text. This text is static. I'm not going to change that text at all. When you click on that, it's going to open up. So its pages stay static. But what I do is I augment it in other ways, and we'll get into that today. So anyway, hopefully that quells your questions about what the textbook is. It's free, and it's there waiting for you. Cool? And there are many more. If you don't like this one, use other ones. It's totally fine. I've just made videos to go along with some of the problems in this one. So if you want to see the solution videos, they're tied to this. Any questions on that before I get into technology? Decent? Okay. You guys spend too much money educationally anyway. I can take a little bit away from you. Technology. Speaking of technology and free software and all that stuff, I like using technology in this course. I think it allows us to play with more meaningful data sets when they're bigger, and when they're bigger, they're more time consuming unless you use technology to help you manage them. So you'll see a pattern in this class. We'll very often crunch a small data set manually, and then we'll move, once we can handle the small data sets, to larger data sets. Like we may start, for example, by analyzing 10 years worth of bench snowfall data. And then we'll go to analyzing 700 caffeine contents of soft drinks. And it's the same exact idea, but the scale of what you're analyzing is larger. Which means you need technology to kind of, unless you want to spend 3.5 days crunching numbers manually, technology takes care of that for us. I'm pretty sure you guys can add, pretty sure you can divide, pretty sure you can subtract, and I think you can take things and square them. So the idea is making sure you understand why you do all that stuff first. Once you understand why, the technology takes it for the ride with us. Which technology do we use? In class, I tend to default to an overhead projected TI-84, which is completely antiquated 1980s technology, but it works. And I think a lot of you guys still have yours left over from your old math classes. If you don't, just pair up with somebody else. That's totally fine. You can work together in class. I got no problem with that. If you've got cell phones, you can add stuff on free apps you can put on your phones. I got no problem with that either. You can do calculations in Google. I mean, honestly, you could type in calculations in Google, it'll do it for you. It's a pretty awesome thing. I don't care what you use in class. It's just that I have written some programs for the TI-84, TI-83, 84. You can have them. and I tend to default to that because it seems like they make you guys still buy them to this day. So I also have an emulator here that you can install onto your PC laptop if you want to just bring your laptop to class. Totally fine, you can install that on there. I made a nod to the handheld technology apps that are out there. I can't keep track of them. They keep coming and going so quickly, which is great. Again, I love that because that's kind of the way education should be. It should be accessible. Of course, it's also impossible for me to follow. My son can download things better than I can. Now he's 7, not even 7 yet. So, but the one that we'll all be using quite a bit is Excel. I love spreadsheets. Spreadsheets are wonderful, and you use them a little bit in 105, a little bit. We're going to use a lot more in 243. They're really, really rad. You can do really, really powerful things with them, especially something called Monte Carlo simulation. You guys ever heard of flight simulators for pilots? Mm-hmm. Monte Carlo simulation and statistics is like flight simulators for any kind of a math problem, not just flying a helicopter or flying an airplane. It's how you can design a process to see if the process works before you make the process and spend lots of money building it. That's cool. Yeah, it's totally freaking rad. Mathematical modeling is one of the neatest branches of math, and I kind of leech it in through the element of prob and stat in this class. So you will be using Excel. I'm assuming, this might be a silly assumption, I'm assuming you've never used it before. So I come at the instructions for my Excel as if you've never used it before. Now I know a lot of you have, so they might be a little bit boring at first. Turn your computer on, click on the little symbol, that kind of thing. But it's okay. Maybe you'll learn something new in the beginnings of that too. But you all have access to Excel. When you log into COCC, you get the same little icons I get down here. So there's your Excel key. We'll hopefully open Excel later and show you some cool things Excel can do. But Excel is not PowerPoint yet. Excel is a pretty rad tool to use. So I'll have you using that from time to time through the course. I think about a half a dozen to a dozen times scattered throughout the course, somewhere in that range. And I'll probably think of other ways to use it. So. Make sense so far? Ask me questions if you got them, please. Okay, so far?
What was that cool thing again you said? Something losing bars?
Mathematical modeling?
Monte Carlo.
Monte Carlo simulations for math. Yeah, Monte Carlo simulations for mathematical modeling. Oh man, so